Okay, so we want to look at parallelograms and with those rules and how to find certain values inside of parallelograms. So let's look at these. We have two different examples. The first one is just with some angles. This actually is a great picture. This angle really represents this. Now you can see that this angle and this 71-degree angle actually make up this whole angle D. And that angle D combined with angle C, these are two consecutive angles. Because this is a parallelogram, these sides are parallel, and between parallel lines, consecutive angles are supplementary. So that means that these two angles are supplementary. So we're going to have -4 plus 6x plus 71, that adds up to get angle D, plus angle C, which is 65, is going to equal 180. So here we're going to combine our like terms. 65 plus 71 is 136, minus 4 is 132. So I get 6x still, plus 132 is 180. So I subtract 132 from 180, and that's going to leave me with 48. So 48 is equal to 6x, or x is equal to 6. And that's it. So that's our answer there. Consecutive angles. Remember, parallelograms are just, two pairs of parallel lines. So if you remember all of the properties from that unit when we looked at parallel lines with alternate interior angles, consecutive angles, then you should be just fine. Here, we also know that diagonals, which are these lines that connect opposite vertices, bisect each other. So this distance here, QW, is congruent to WS, and PW is congruent to WR. Now if we look at these, we can see that QW is x plus 3, and WS is -3 plus 3x. So because these are two halves, two bisected parts of this diagonal, they must be equal to each other. So I say that x plus 3 equals -3 plus 3x. And so what I can do is I can combine x from both sides and adding 3. So I get 3 plus 3, which is 6. On the other side, here the x's cancel out, and 3x minus x is 2x. Divided by 2, I get that x. That's not a very pretty x. Let's make that a little bit better. We get that x is equal to, that's not a very pretty equal sign. We want this answer to be just right. 2x equals 6, x equals 3. That's our final answer there. So again, with diagonals, they bisect each other inside of a parallelogram. They don't equal each other. They're not perpendicular to each other. They just bisect each other. Only for parallelograms. For other polygons, there are other rules. But if you know this, then you're set for parallelograms.